Okay, I'll directly start with constraint programming model. Okay. Um, for the last two parts, we have completely discussed uh, mathematical optimization, uh, only linear programming, non-linear programming, integer programming, so on and so forth. Uh, Now this is a completely different paradigm. So math modeling, linear programming, and uh, uh, all of its types, including integer programming, non-linear programming, they are a completely different class, and constraint programming are a completely different class of uh, solution techniques. Okay. Uh, Although they are different class, but they can solve same common problems. Okay. For some reasons, for some in some cases, uh, math modeling is better. In some cases, constraint programming is better, especially for the cases where you don't want to find optimal solution, where you are fine with getting a suboptimal solution or just a feasible solution. Okay, I'll give you examples of that. Hi, Vivek. Okay, uh, so hmm, these are set of math math models, and these are set of CP models. Okay, so there are some common problems that you can solve both using CP as well as optimization. Okay. Uh, Whereas in mathematical models, now with in terms of problem statements, okay, here you in CP models you can have both optimization and feasibility. But in optimization models, especially mathematical optimization models, you only have optimization. Okay, like the objective is you have to have some kind of objective for it to even start solving. If you don't have an objective, it will not start solving because it doesn't know where to go. Whereas in CP, you don't need to have an objective function. You can have uh, an optimization. Either you can have just a feasibility function, just give the solutions, or you can have a objective. So both are fine. Okay. Uh, most most important difference between optimization model and CP models are CP models will always be discrete in nature. Okay, so these models are always discrete in nature. What do I mean by discrete? All the variables in this will only be integer or binary. Okay, okay, but in math models, the variables can be anything. The variables can be real, integer, okay, binary, continuous, whatever, real and continuous is same. But here it will always be integer or binary. Uh, and that's what we call discrete. Okay, so CP is specifically for discrete optimization, whereas optimization models are mathematical optimization models can be both discrete as well as continuous in nature. Now, the moment your problem needs to have a continuous variable, you cannot think about CP. You can only think about CP if the statement of your problem can be discrete in nature. The best example is what we discussed last time is the routing example. In routing, the solution is always discrete, where which places you want to go. Let's say each place is a point, integer point, okay, variable. So the path could be 2, 5, 7, 9, 1, so on and so forth. Okay. So each path is discrete, each node is discrete in nature. Okay, which kind which kind of item to put in which truck, that is also a discrete quantity in nature, meaning uh, whether this particular guitar will fit in first truck or second truck or so on and so forth. So that is also binary variable. In such cases, we can solve using CP. And most importantly, if uh, if you have something like a uh, continuous variable, how much uh, in uh, percentage, like with three points accuracy or 5 points accuracy, okay, um, of some quantity do you want, that is a variable. If we have a continuous variable, we can never use a CP uh, model. Okay, you can change some kind of continuous quantities into discrete quantities by multiplying and coming to a scale. But other than that, you cannot have different uh, C, CP models for continuous variables. Okay, okay. Now you can each constraint that you can use in mathematical optimization can be used in CP. Okay, but CP has extra additional constraints. What do I mean by these additional constraints? Constraint programming is a logical paradigm. So you can write the models logically in constraint programming, whereas in mathematical modeling, you have to write the models mathematically. So, and mathematics is a part of logic. So anything that you can describe mathematically, you can also describe logically. Okay, I'll give you a very good example. Okay, there is an there is a constraint which is called all different. Okay, in this constraint, all the variables we pass x1 to x2 and so on and so forth, the constraint will impose that each of this variable will have a different value. You cannot write this mathematically like in the same way. It won't be easy, definitely, to write. Like you have to write all the combination of all the variables in mathematically. If you want to write x1 is not equal to x2, x2 is not equal to x1, and so on and so forth, x2 is not equal to x3, and so on and so forth. So all different constraint is a constraint that CP allows you to make, because the way it solves is not mathematical. Mathematical modeling has to be solved mathematically, meaning searching in the solution space, the convex hull of solution space. But discrete problems are not in the convex hull. Discrete problems uh, can be logically defined, and you can have heuristics to search for them. So that's why you will see additional constraints, like all different. Cumulative is another constraint. You can say, when is cumulative used? A very good example is uh, if you have different points. Okay, you want to make sure that you fill enough petrol through the path. Okay, and you can take any path. Okay, at each node you can fill the petrol. Okay, but your mm, available mileage, okay, will not be enough if you take some path. So if you take this path, okay, you will not be able to meet with the mileage, uh, meet reach here. Okay, and because here you don't have any petrol pump, for example, okay, you'll have to go you'll have to go here, but this path, the distance is not enough. Okay, let's say the distance is 150, but you have only 70 kilometers left in the vehicle. So if you want to say that the solution, the path, okay, that you take should not exceed the tank capacity, that is, let's say 300-kilometer tank capacity. Within 300 kilometers, the path should always find a petrol pump. Okay. So if you want to state that, okay, there is a way you can state that using cumulative constraint. Okay. In constraint programming, you can have something called a domain specific constraint. Okay. The constraint which are defined over domains. Okay. Each variable will have its own domain. So let's say x1. So before, let's say if the variable is a continuous variable, we say it's between 0 and 5. Okay. But in CP, it cannot be like that. It cannot be between 0 and 5 because it's not a continuous domain. So it can only be 0, 1, 2, 3, 5. Okay. So you can have domain specific constraint. What does that mean? I can say that domain of x and domain of y cannot be same numbers. You can add a constraint like that. You you know what I mean? Okay. Um, okay. These Other than this, you can have, or you can also ask CP to search in a specific way, which you can't do in optimization. Like for a set of variables, you can say that you start these variables from the highest value, from the highest value of its domain. You can say you can start the search from the lowest value. So you can also tell how to search for a solution. In MIP, you cannot tell how to search for a solution. It will do its own way of you can choose the technique to search, but you cannot tell how to search. Okay. Uh, a very good example is, let's say that you want to make sure that you want to fill uh, as each truck should be as much full as possible. Okay. So which items to take? So you should take that items from the uh, descending order of their weight. So increasing quantity of the weight. Okay. Like decreasing quantity by the weight, like 100 kgs is the heaviest item. So next is 95 and 94. So you take in that order. You give solutions in that order. Okay. You can have soft constraints, or soft constraints are also known as lazy constraints. uh, I'll just know that it's okay if the constraints are uh, violated. Okay. But it's good to have. So you can just state that. You can also do this in mathematical models, but it's just going to be a bit more difficult. Okay. There is a constraint which says apply only if this variable is true. Okay. Um, okay. So just by saying that CP is only discrete in nature, you can just start thinking about all the different kind of problems uh, CP can help us to solve. Okay. Only discrete. Just think about all the problems in nature which are discrete. A timetabling problem is discrete in nature. Finding timetable each week, that is discrete in nature. Okay. A rostering problem is discrete in nature. Finding rosters for nurses, basically giving them their weekly or monthly schedules, or for crew, uh, you know, pilots and so on and so forth. They will have rosters. That is also a discrete problem. You just have to state which flight you will take when, so that you don't have to describe any sort of quantity in a continuous form. Okay. So just by thinking that it is discrete, that CP can solve. So whenever you're presented with a problem and you see that it's discrete, just first go with CP. That's, you know, that's the best option to choose. Okay. Uh, Sudoku is a very beautiful CP problem. Okay, that's why the puzzle is stated here. Sudoku, if you must have seen, it's a 9 by 9 uh, matrix, and uh, every consecutive 3 by 3 matrix should have 1 to 9 all different values. So just one constraint, all different constraint can solve the complete Sudoku. So you just define the domain, you define all different constraint, and you can solve complete Sudoku. And I can just give you a quick example of how that can be done. Let's say you have a 9 by 9 Sudoku block. Okay, so uh, all of these are 9, all of these are 9, so on and so forth. Okay, so each variable, let's say that variable is x x ij. So uh, 1 1 to 9, and j goes from 1 to 9. Okay, so this is like a matrix representation of the complete 9 by 9 block. uh, all I have to do is, so x, all of these variables, so these are some x1, so these 9 variables, I have to say that these variables apply all different on these variables. Okay, apply all different on, I'm sorry, just one moment. Apply all different on these variables, apply all different on these variables. Okay, um, and so on and so forth. So all the all the 9 blocks, okay, and all the 18 diagonal as well as vertical slots. Just one moment. Just because these devices are connected, I have to deal with. Yeah. Okay. Coming back. Yeah. So just all different constraint will be enough to solve uh, a complete Sudoku. So you just have to uh, 9 plus 18, that's somewhere around 27 different, all different constraints will be enough to solve a Sudoku. All you have to ask the CP model is to give all the different types of solutions also, if your Sudoku can have multiple solutions. This is a very interesting problem in constraint programming, where some Sudokus can have more than one solution, and you want to solve that. And CP is a very good way of doing that, because human beings cannot solve uh, it's very difficult for a human being to solve Sudoku which has more than one solution. So it's basically just less numbers to hint you to the solution, and then that just space is expanded. So this writing mathematically is going to be very tedious, but now you write it logically. Okay. Okay. So these are the applications. Just remember, anything discrete is CP. I'll go ahead. Okay. Just like we defined set covering before in using math models. So set covering problem is basically saying that each set, each variable in a particular set should be covered at least once. Okay. It can be that you can have more than one variable active, you can have two variable active, but at least one, more than once, the set should be covered. Okay. Um, This is also a CP problem. So it's the version of CP is basically just the same. Okay, greater than equal to 1. Set partition is the same. If you remember what set partition we described before. So xi equal to 1 for all ij belonging to si. Okay. Here the only difference is this is equality and this is inequality. Okay. This can also be uh, written using CP. And if you see, all different constraint is also type of set partition constraint. Okay. In set, you will say that um, only one of 1 to n variables is active. Exactly one of 1 to n variables is active. Uh, and when you think about CP, it's also the same. Like when I talk about all different in terms of Sudoku, what you're saying, only one value can be taken by the complete variable. Okay. Uh, okay, in that set, and that value cannot go to any other variable in that set. So a set partition is just a different way of all different is just a different way of writing a set partition problem. So you can think over it how to uh, write any set partition constraint into an all different constraint or vice versa. Okay. Set packing is the same problem that we discussed last time. It is basically stacking different items in a truck or in a box. Uh, okay. Just to make sure that you utilize as much space as possible in the box. So there is a problem called Harmony Hub in the. Please check out Harmony Hub. Okay. Uh, I have just shared the link in the chat. Somebody has asked for the link. I'll just share the link again if others have not seen. Okay. Harmony Hub is a model that uses set packing using CP, constraint programming. So it's a very good example of constraint programming problem that solves both routing as well as packing stuff in a container. Okay, so it will that's it's a real life problem for music instruments, shipping of music instruments. Okay, an abstract problem is also a CP problem. Like in an abstract, you just have to say which item goes into a box and which does not go into the box. It's just a binary variable. So if there are 10 items, you want to. An abstract problem is basically maximizing the value of a bag that contains some items. So if your bag can contain only 15 kilograms, according to the airline rules, then you will try to fit as much value as possible in that bag that you can utilize. Okay, that's an abstract problem. So that value is defined by some variable. Okay, and each item will take some space. So there is a space constraint. So knapsack is bin packing plus optimization. You want to minimize the space. Okay. Um, you want to, sorry, you want to fill the complete knapsack. Okay. And maximize the value. Okay. Uh, so this also is a CP problem. Traveling salesman problem is also a constraint programming problem. Vehicle routing problem is also a constraint programming problem. Okay. Network flow problems, all the network flow problems, scheduling problems, or a constraint programming problems. Facility location problems. So all of these problems are discussed in first and second lectures that I will share the link of in the end. Just remind me. Okay. Portfolio optimization is a constraint programming problem as long as you convert the values into integers. So most of these risk values and return values are not integers, but you can easily convert them into integers. Okay. I've shared this PDF Please feel free to come back if you have any questions. Okay. In the interest of time, I'll move forward because I want to keep a good amount of time to have Q&A so that we can uh, exchange more ideas. Okay. Okay. Cutting stock problem is also a constraint programming problem. Okay. I want to spend some time in modeling languages. Okay, there are different types of modeling languages. Okay, and I want to make a claim. If you know one modeling language, mathematical optimization modeling language, you can work on any modeling language. So, if somebody says, "Do you know Julia?" Okay, uh, do you know Jump? Sorry, Jump. Jump is a modeling language in Julia. uh, or do you know pulp, or do you know IBM ilog uh, modeling language, okay, or something else. uh, the claim is if you know any one of them, you'll be able to work on any of the models, okay, because all you have to know is how to build the math or constraint programming models, okay. uh, because you will soon see that each of these models, each of these modeling language have a very similar syntax, okay. And I've taken this example called capacitor facility location problem, and I've written them in different modeling languages just to give that uh, idea to the reader that it's all the same. You know, uh, if you know one of them, you can confidently say that you can program or build in any other if the opportunity uh, comes or situation comes. Okay. What is a capacited facility location problem? Uh, Quickly, if I give you an example, there are different facilities. Okay, facilities are places, warehouses. Okay, and these are candidate facilities where you can use these places as warehouses. Okay, you want to choose which facility you will rent or you will buy in order to meet with the demand. Okay, so let's say you have some demand and you have so many facilities. You will choose these facilities, and each of these facilities is capacity, so it can only uh, handle some set of uh, weight, okay, or quantity. Okay. What are the sets in this problem? The first set is again set indices and variables parameters. This is taken in the first lecture. Okay, uh, I'll share the link. You can go back and forth and see uh, how these work. Okay, so first is a set of all the facility locations. So let's say that these are set of all the facility locations. Okay, the points are all the set of customers. Okay, X means you choose the facility. No X means you don't choose the facility. Just to give an example in the diagram here. Okay. So I is a set of all the indices and J is for facility and J is a set of all the indices for customers. These are the parameters. Fixed cost of opening a facility. Okay, that's a fixed cost. Maybe that's a down payment that you want to give to the warehouse guy. CIJ, cost of serving customer J from facility I. So this is based on distance, as you can guess. So each customer can be served from by a different facility. Okay, so each cost of serving the customer from different facility would be different. So this one customer is served. Sorry, this one customer is served by so many facilities. Okay, so what is the cost? Each cost, this Cij, each Cij will be the cost associated with the parameters. Okay, um, each customer will have a particular demand. How much each customer wants, Okay, this is a daily distribution problem in Amazon. Everywhere you see, I mean, if almost each problem you will see is somehow the other described by a capacited facility location problem. Um, CIJ, each point will have a demand. Okay, D, J. So each point will have a demand. Each customer will have a demand. Okay, and each facility will have a capacity. Okay, so you can only fulfill so many customers, so many facilities as the facility can provide. Okay. Mm. 10 more minutes. Variables. Yi is a binary variable, whether or not you choose the facility. Which says what, sorry, no, Xij is a continuous variable which tells how much quantity uh, each facility will serve to each customer. Okay. So a customer can be served by multiple facilities. Okay. The objective, I'll quickly go through the model, and then because I have to also go through the code. The optimization model is pretty much simple. You just want to minimize the total cost of setting up each facility and the total cost of distributing items to each uh, customer from each facility that you have chosen. Okay. So you minimize Fi, Yi, some more all I, C, and plus Cij, Xij, some more all F and C. Okay. First constraint is you want to satisfy the demand at each J, each customer point, you want to satisfy the demand. Okay. So every Xij that is coming to that customer from different I's, okay, should fulfill whatever the customer wants. The customer wants 100, every from every place you want to give 20 or so on and so forth to meet with the demand of 100. Um, Capacity. Uh, so capacity is a feature of each facility, F. So if a facility is helping with so many customers, it can only help so many customers that its capacity can take. If the capacity is 500, it can only serve so many customers. So each customer is 100, 150, 150. There is another customer with 200 demand, but you cannot fulfill this. It's not possible. So that is the constraint the that is imposed on facility. A binary variable, binary variable constraint and non-negativity constraint. Again, this has to be explicitly defined in optimization models. Although this can be defined during variables itself. Okay. Now the same problem is coded using Gurobi. Okay, Gurobi has a package called Gurobi Pi. Okay, which have these two classes, model and GRB. GRB is basically all the constants that you have to use for Gurobi. Um, this is a Python. This is more of a Python range. You add range of f set to define a set. You create a model object from the model class. Okay, and this is the object oriented way of optimization modeling. First, you define a model. The abstract model already exists almost for every modeling language like Gurobi or something like that. Okay, you have to create a object out of that class of model. Okay, and now everything, all the variable constraint that is used, that is created using this object will be in this model. So in this way, you can have multiple models in the same code base. So you can have multiple models, they can interact with each other in the same code base. Let's say you want, you uh, create one model, you take the solution, you take give the input to another model. You can do that because this object oriented way of modeling can help you do that easily. Um, so you can also set objectives using the same model object. So model object will generally have adding variables, add objectives, add constraints, okay, solve, get solution, okay. Generally, every modeling implementation is different. Every language implementation different, but you'll find all these features, okay, all these functions available. So these functions will help you define the model and get the solution from the model. Okay, so Gurobi will let you use set objective. It will let you use add constraint to add each constraint, and in the end, you will say optimize. Okay, and the model object will get the solution. Now it's just about how you interact with this model object and get the solution. That is up to you. Okay, and this is the last thing that you do generally do with an optimization model. You optimize it. Okay. Now in the same Python environment, this is Cplex. Cplex is I think the second best solver after Gurobi, mathematical optimization solver, and this is a Python API. Although if you want speed, C++ is better for Cplex modeling, but Python is everywhere, so people mostly use Python. Uh, Cplex has decision optimization Cplex, DOCplex. Okay, this is a library. In that, they have mathematical programming, that is MP. Now they have MP because Cplex also provides CP. Okay, which is not so you can take CP model also. Okay, so Docplex is not just a uh, uh, MIP solver like Gurobi. It is also CP solver. Okay. Uh, this is defined in the same way because this is a feature of Python. Now you see model, just the same way. Binary variable dictionary. This is a function that just directly creates a dictionary. Uh, Even Gurobi gives that, but it's not needed all the time. This is a continuous variable matrix. Oh yeah, you can also write the model using a matrix, and this feature is also there in Gurobi. It's a feature to describe a complete matrix. So if you see, the shape of the matrix is defined by f cross c, and this is a continuous variable matrix. Okay, and because it's a matrix, you'll have ij iterable over that particular variable. Uh, Model dot minimize. Okay, now what's the difference? There we had set objective. Here we had minimize. Okay, there here you had set objective, and the second uh, argument. So there are two arguments that are passed in set objective. The first argument is the objective function. Okay, and the second objective is whether you want to minimize or maximize. The second argument is whether you want to minimize or maximize. But here, if you see, here you directly have a minimize function. You can have a maximize function. You also have a maximize function for the same reason. Okay, just a slight difference. It doesn't make much of a difference. The continuous variable matrix can also be defined using Gurobi, pretty much in the same way. I've just used it here just to show that you can. This is another way of modeling the problem. Yeah, you add the two demand and capacity constraint and you solve it. The same problem is solved using two different optimization solver APIs, and both of them pretty much are the same. If you just even look at it, you can just guess that they are the same. Pyomo. Pyomo is a little different, little slightly, because there you can define an abstract model. Okay. Pyomo has, but I will describe concrete just to show the same example. Okay. A concrete, you take a model the same way you take a model class, get a model object, you create the variable. Now here variables are defined inside the models itself. So model.x and model.y. So the moment you create something after the model dot, okay, you can assign it a particular variable class. So here, if you see, nothing is inside the model. Everything is supposed to be called from the environment. So Pyomo has an environment, and you get all these from the environment. You get the model, you get the variable, you get the objective, you get the constraint, get the binary. So this is not as object oriented as other models, okay? But everything else is pretty much the same. You create object using the objective function, you create variables using the variable function. Everything goes into the model part. The name can be defined in any way. We create demand using constraint function. And from solver for factory, you can use different solvers. So PyMO is more of a general purpose uh, modeling language. It has a specific uh, difference from classic modeling language. Uh, so it can solve Gurobi or Cplex or any solver that you have. Okay. So far, if you see, the modeling language is pretty much the same. It's just how you see represent the functions inside a class and one is outside the class. AMPL. Um, AMPL is the most mathematically inclined language. Okay. Why? Because you don't need to know programming at all. All you need to know is how to develop math models, and you can just use it. Okay. Uh, it is meant for only people who want to focus only on models. They don't want to focus on any other uh, computer science uh, uh, things. Okay. Um, so here you define a set. So if you know modeling, you know uh, AMPL. Okay. You define a set. You define params in the same way. Uh, define variables. You see the set. So whatever you have defined as a set, you define a variable on that set. Okay, so this variable will be for all the elements in this set F. Okay, X will be a variable that is over all the elements in F, the combination of FC. Okay, facility and location, facility and customer. You minimize the total cost. You want to specifically say minimize or maximize. You want to describe a function, describe an expression that is called total cost, and that expression is here described in this way. So sum over all I in F, such that I F into yi plus sum over all I in F j in C, Cij times Xij. Okay, this is what you want to minimize. Okay, you define constraint in the same way, just you have inequality in between. But this is pretty much, you know, math modeling. You can just see a few examples and just, if you have a model, you can come quickly code in this language. It's that easy to model. Jump is a modeling language that is used in Julia. Okay. Uh, this is Julia is a different programming language, just like Python is. Uh, Jump gives, when you call jump, you can get all these @ functions, okay, and the model functions. Okay, so you call jump, you get the model function. You have to call Gurobi also. That is a different environment inside Julia, and you have to pass a Gurobi optimizer inside the model before defining the model. Okay, variable. You define a variable. So this has a different function. A variable function. This is a function that takes two arguments, one model and another uh, mapping of the variable. I'm sorry, three arguments, mapping of the variable and type of the variable. This is the third argument. So if you see which model this variable is created on, what is the mapping of the variable, and whether it's binary or continuous. Okay. Okay. This is basically a different variable. By default, it's a continuous variable. If you don't pass binary, it takes continuous by default. Uh, so that's why only two arguments model as well as variable, and greater than zero. This is a constraint on the variable saying that this variable will always be greater than zero. And because this is a binary variable, this is constrained by 0 and 1. Objective is defined in the same way. You pass a model object inside, you pass whether you want to minimize or maximize inside, and then you pass the objective function. Okay, so you take the objective function, uh, function I mean, in the programming sense, and you pass the model, you pass whether you want to min or max, and you pass the expression. Again, if you can write math models, you can code in this language. Okay. Google OR tools. I will quickly show here. Solver is what is called. Okay, and solver has boolean variable. The boolean variable is iterated over all I, and you create a dictionary of variable y. This is y over all I, and you create a dictionary of variable x over all ij, and you create a number. Okay, this is a number 0 to infinity, but it is always an integer, so you don't have to specifically say that it's a integer or binary. This is a boolean variable. um, Objective function is solver dot minimize, and you pass the entire expression. Constraint is solver dot add. So just by saying add an expression, you can uh, add a constraint. You say solver dot solve, and it solves and gives you the status whether it's optimal, infeasible, unbounded, or uh, uh, feasible. Okay, this is what my claim is. You don't need to know all languages. You know one, you can be confident that you know any other one of them. You know math modeling, you can be confident that you can easily code in others. Okay, and these days, because you have LLMs and stuff like that, you can easily get the gist of the modeling uh, pretty easily. Okay, these skills are transferable. You know Gurobi, you can use Cplex solver very well. So but the HR in optimization don't know that, so they will search for Cplex developers. Uh, but if you see, yeah, I mean, they have Cplex experience. It adds a lot of value, but it is more important that they know math modeling than they just know Cplex, because uh, it's not important that you would be just using Cplex in the future. Okay. Um, Oh, okay. We are way past time. Okay. That's it. I'll just keep this time for questions. And I will also share the link to the previous two and this one by tonight. Video on YouTube. Okay. Any questions?
Hi, Abdul. Just a question, but about CP
Mhm.
is like how we know our solution is close or far from an optimal solution. There is a
Mhm.
way to do that, or just not. I know that maybe we can like to do the mathematical model, like compare, but maybe I don't want to do the mathematical model. I just
Yeah.
want to be. It is a report, a log that tell me how
Mhm.
far is how good is my solution is.
Yes. Um, Google OR tools provides optimality gap. Okay. Uh, but there are some other constraint programming models which don't. But at least Google OR tools can tell you how good your solution is based on MIP gap.
Oh, then it's so good. Thank you so much.
Uh, any other questions? I hope everybody found the PDF for this.
Sorry, sorry. What?
The
What?
PDF, I have shared this PDF.
Okay. Yeah, man, this PDF is like gold. Thank you so much, man. I really, I really like it, man. I think I'm going to take to show to the other people. It's really useful for me. Thank you so much.
You're welcome. This is very kind of you. Uh, I just wanted to have a comprehensive document to uh, have more practical approach. Uh, and I'm thinking I'll add more content to this PDF and share another version soon.
But this way is really fine for me. Really, it's really a lot of content. Is really is going to be really useful for me.
Nice.
Thank you so much.
That's really good to hear.
Hello, Tool.
Yes, Gautam.
Uh, uh, did you mail this PDF or is it? Did you upload it somewhere?
I've uploaded on Discord. Okay, on the server.
Okay.
Uh,
Can
can
you please share the link of that?
Yeah,
This was my first
quickly.
lecture session.
Okay. Oh yes, I'll share all the sessions by tonight. Okay, and I'll share
Sure.
the link for OptiVerse Discord server right now in the chat. This link is only active for 7 days. Okay.
Okay, Tool. Thank you.
Yeah. Okay. If there are no other questions, we are exactly on time.
Atul,
Oh, hi,
I have one.
Manikanth. Yes.
Uh, Actually, there are so many solvers and so many modeling languages are there. Na? Like how we can understand like which will be faster for which scenario kind of thing.
Hmm.
Like how to choose one among all of these modeling languages like Gurobi or Cplex. Like, is there any way to choose? Like, I have a mathematical model for a case, then I
Mhm.
need to choose it. Na? Which one is suitable more? Like, which one will be faster and quicker kind of thing. So
Yes,
how?
yes. That's a really important question. Uh, One is scale. Scale means if it's a very big problem like Amul optimization, milk optimization problem that is there in the report, that's a very, in scale terms, it's a very huge problem. So if it's a very huge scale, then you can say, and it's an LP. If it's an LP, even open source solvers can solve it. LP is very easy to solve, millions of rows and columns. Okay, but if it's IP or MIP, integer, where you have integer variables, then you need to use a good solver. Okay, for a high scale. Okay, uh, and which modeling language to choose, I think should be dependent upon this which solver you choose. So the solver should be primary, modeling language should be secondary, because solver will have more of a problem focus. You know what I
Uh,
mean?
yeah.
So let's say the problem is LP problem. Okay,
Mm.
it's a very big problem. Then I will choose open source solver because I don't have to pay, and LP
Oh,
can be solved by open source. Then
okay.
what I will do? This solver supports which API? Python. It supports C++, so on and so forth. But Python is the best. I know Python. Now I'll use Python.
Okay. Okay.
Okay. Um, and if it was a IP problem or MIP problem, and it's a very big problem, then I can choose between Cplex and Gurobi.
Okay.
And let's say Gurobi is giving us cheaper and it is fitting and so on and so forth. Or we are already have the license, so we use Gurobi. Then with Gurobi, the best is using Python. You know,
Okay.
that, I think that thought process is better than first fixing the language to code in, and then coding it, and then choosing a different solver. I mean, you can go either ways, but this is a good way to do.
And some solvers, they use a different way of approach for solving it now. Like some will use different kind of algorithms, back end like thing. That how we need to know, like on what basis this particular solver is preferring, like which way of solving algorithm. Like
Hmm. Um, for for CP, some open source solver they tell you, but closed source solver don't tell you actually. So Cplex and Gurobi will not tell you how they solved it. They will give you some information in the log. Okay. Uh, so like you can say that as long as you know what type of problem you're solving, okay, very well, and what is the scale of your problem, okay, then what algorithm is are used to solve it mostly, okay. So if it's a MIP problem and the scale is very big, the generally algorithm is branch and bound other than this, okay. So that way you can know. A solver will also tell you whether it is using branch and bound or stuff like that. That is another way to know. Yeah.
Atul, as a perspective of a student of OR, like we used to study most of the things, right? Like Gromori cutting plane kind of thing, and fractional cutting plane algorithms. Like
Yeah.
when we are able to use these techniques, like whenever you are saying like the company of the solver, they will do it kind of hidden magic box kind of thing. Then as a practitioner, how we can use our like own approach kind of thing. Like, is there any way?
Mm, I generally do not uh, go or do not try to do something from scratch if it already exists. Uh, because I think it will be time consuming for me. That is uh, like that is a thought process. But if I want to do it from scratch, okay, I can. Like you can build a complete solver all by yourself. But in the interest of problem, I don't think one should, because there are really good implementation of such algorithms done by big companies and open source community and stuff like that.
No,
So
means like, is there any open solver where we can tell the solver to do in this method? Like,
yeah,
if it done with branch and bound, can we ask for like go for cutting plane algorithm, or like
yes, you can do that.
so like any which solver we can do on this? Like if I want to start with which is the
Yeah,
best solver to work like that? Means
I
for the
would
same problem, I want to try with a different approach, kind of.
I would suggest Gurobi. Gurobi has a lot of parameters.
Okay, but it is not a open source thing now. For students, I think it is. We can use until unless we are in the university network region.
OR tools, try OR tools. CBC
Okay,
and OR tools. CBC and OR tools, both are open source.
okay,
OR
Atul,
tools
thank
is
you.
CBC is used inside OR tools, but both are open source. You can try CBC and OR tools.
Okay. And this like yeah, and for sometimes now for larger models, as you said in Amul, the time of building the model and defining the variables and the parameters, it is taking long time. No,
Yeah,
like
yeah, yeah.
that time, is there any way like how to cut short the time taking to build the model, kind of thing? Means
That
how
is
a student should approach at that point of time, how he needs to think, like what way he need to go, like.
um in my opinion, the best way to think is break the problem into small chunks. If it is slow, if the building is taking very less time, then you have to find out more optimal ways of building the model. Okay, because you have to build the model, maybe different way of using the loop, different way of uh, programming, programming that loop or mapping or stuff like that. Uh, so it's like an iterative process, I think. Okay. Uh, you can't know everything beforehand. You get stuck. I think this is by default true for anything. So you get stuck somewhere, and then you try a different approach to do the same thing. But you know that you want to do this thing. You know that you want to model it, and it is taking half an hour. But now you want to do it within 5 minutes. So you change the approach of building it. Uh, I think that way of thinking is better rather than figuring out beforehand. You can figure out beforehand how long it will take to build it and so on and so forth. Uh, Maybe you can also guess that after some time if you're used to it. But I think trying it is the best approach. First trying
Okay.
it and then trying to uh, analyze it and then get better.
Okay, Atul, thank you.
Atul, just another related question. So basically, for very large scale LPs, in your experience, or I mean, have you tried that? As Mosaic, which is kind of built on an interior point method, right?
Yeah.
Uh, does that outperform Gurubi or things like that? In your experience, basically, if you have tried that.
Um, Personally, I think I have seen Gurobi to be the fastest solver.
I mean, for very large scale, like 40 million decision variables, something like that, basically, right? On that scale of LP.
Yeah,
Basically, because interior point method, I mean, that's what Mosaic claims that basically that's
yeah,
like faster
yeah,
algorithm. So,
yeah. Definitely, Mosaic can solve LP that big because Mosaic is a firstly because it is LP. I think LP is very easy to solve. Even open source solver will be able to do that big a problem. I think, uh, at least to some level of accuracy. Uh, you can use Gurobi, but you don't need to because uh, if it's LP, you don't want to uh, expend so much. Gurobi is only good when you have MIP.
yeah, sure.
Okay, we are a few minutes over time, but I guess that's okay because we extended the call. So if there's any other question, okay, I will share the PDF. I will also share uh, the video by tonight. Um, I've shared the link for the Discord uh, server, and there is a link for music shipping optimization uh, for the CP example. Yeah. Okay. Thank you, everyone.
Thank you too.
Vivek.
Bye.
Thanks.
Hi, Vivek. Oh, is that a bye? Okay, thank you.
Hello.
Hi,
Yeah,
Vivek.
you said you will share the link for last previous two sessions. Where
Yes,
will
yes.
you share it?
I'll share it by tonight
Where? Actually, on Discord or on
on
mail?
Discord itself. On Discord itself.
Okay.
Yeah.
Okay. Thank you.
Thank you.
Thanks, Atul.